So in this video, we are going to look at the last derivative rule, which is called the chain rule. It's one that's used pretty often. And the chain rule is used for a composite function. So a composite function is a function inside of a function. And for example, like this function of 4x squared minus 3, that quantity squared is a composite function where our g function, like that inside function, would be the 4x squared minus 3. And then my f of x would be like x squared. That's the outside function. And then another example would be this, like y equals ln of 4x cubed minus 2x plus 5. So again, that inside function is that 4x cubed minus 2x plus 5. And the outside function is like the ln of x. So when we take the derivative, we use this rule. We find the derivative by doing f prime, which is that outside function, and then we keep that inside the same, g of x the same, and then we multiply that by g prime of x. So in words, it's the derivative of the outside, keep the inside the same, and then multiply by the derivative of the inside. So if I want to differentiate this using the chain rule, this piece inside would be like my g of x. And then the outside piece would be like the squared part, like we talked about. So if we take the derivative, what you would do is you would take the derivative of like x squared, but with this being your inside piece. So you would pretend the squared is what you're taking the derivative of. So you move it down to the front, and then it would be 2 minus 1 to the first power. Okay, so that would be that outside, and I'm just leaving parentheses for now. And then what we do is we keep the inside the same. So this does not change at all. And then we multiply by the derivative of that g of x, that inside piece. So this derivative of this inside piece is 12x. No, sorry, 8x. Right, because 4 times 2 is 8x, so we would multiply this by 8x. And so this, again, I could multiply the 2 and the 8x, so I'd get 16x, and then 4x squared minus 3, and if you really wanted to, you could distribute. Now, if you struggle with seeing that, another option is sometimes we rewrite this function in terms of another variable such as u, and so we let the inside be u. So it's 4x squared minus 3. And then what I'm going to do is I'm going to replace this inside with u. Okay, so it's really just u squared. And then you can take the derivative of this. So you would take the derivative of u, which is 2u. And then because we're doing it with respect to x, we take the derivative and we multiply by du dx. This is like represents that inside derivative. So then for du dx, we would take that derivative, which is again 8x, and then it would just be replacing these pieces. So it would be 2 times what our u is, which is 4x squared minus 3, and then our du dx, which is 8x. So that's the other way to think about it. If like finding the outside confuses you, you can always let u equal the inside and then do it that way. Okay, so let's look at another example, and this one is with natural log. So in this case, my outside function is the ln, and my inside function is the 4x squared minus 2x plus 5. So if I do it first kind of with that u, and let my u be that whole inside, and then we'll take the derivative of that. And you can write u prime as well, that's fine. So this is 4 times 3, which is 12, x squared minus 2. And then I'm going to replace this to be ln of u, because that might make it easier for people to see. And then when I take the derivative, derivative of ln of u is 1 over u. And then we multiply by the derivative of u, which is du dx. So that's how, and then you would plug back in our functions. So it would be 1 over this 4x cubed minus 2x plus 5. And then you would multiply by this 12x squared minus 2. And really when we multiply it, that just goes in the numerator because we're multiplying by 1. If you're writing it the other way, just like with jumping right into it, the key thing is you have to remember ln is 1 over, and so it's 1 over whatever's inside of it. So that's 4x cubed minus 2x plus 5. And then we multiply by the derivative of that inside, which is 12x minus 2. Okay, and then when you simplify it, you would get that. So sometimes people like a rule for ln, which you could do. So if you have ln of g of x, how it always works is it actually always ends up being g of x in the denominator and then g prime of x in the numerator, okay? Because it's always 1 over this, and then we multiply by the derivative. I can write it out. It's like 1 over g of x, and then we would multiply by g prime of x, and then that's why we get this. So if you get confused, you could also just memorize that rule. But that is how we do the chain rule.